This question is asking us to find the critical numbers for 4 different functions. Critical numbers occur at places where the derivative is equal to 0 or where the derivative is undefined. Undefined usually comes from division by 0. So first up, we have f of x is equal to 1/3 of x cubed minus 3x. It's a polynomial. It's defined everywhere. Its derivative will be a polynomial, and that will be defined everywhere. Keep the 1/3, bring down the 3, and take away 1 from the exponent to get the new exponent. The derivative of minus 3x is just a minus 3. These guys cancel, and you're left with x squared minus 3. You're going to set that equal to 0, and that's going to mean that x is equal to plus or minus the square root of 3. Those will be 2 places where your derivative will be equal to 0 at. Don't forget the plus or minus. It will be x squared equals to 3, and then you'll take the square root. So those are your critical numbers in that question. Letter B. In letter B, we have f of x is equal to x squared on top of x minus 2. Now x equal 2 is not even in the domain. Okay, when we go to take the derivative, we'll square that x minus 2. We'll bring that x minus 2 up to execute the quotient rule. Take the derivative of the top, which is 2x. Put a minus sign. Leave the x squared alone. Take the derivative of the bottom, which is 1. Given us, distributing across here, 2x squared minus 4x minus x squared. And that's all on top of x minus 2 quantity squared. Combine these x squared terms together to give you 2x squared minus x squared. It's just an x squared. So we have x squared minus 4x, and that's on top of x minus 2 quantity squared. Derivative will be equal to 0 when the numerator is equal to 0. If there's a fraction. And so x squared minus 4x equals to 0. We can solve that by factoring out the x and getting 2 values. Either x is 0 or x is 4. And technically, where the denominator is equal to 0, then that's going to be a critical point too. And this is going to be where your derivative is undefined at. And so that's x equals to 2. But x equals 2 is not even in the domain of the function. So there we go. So I would say the critical numbers are these guys. And this is not in the domain. How can it be a critical number if it's not in the domain? Okay, letter C. In letter C, we have x. Oh, let me write out f of x is equal to x times. Now, careful here. Very tricky. You want to sometimes there's simplification that you can do that actually ends up being wrong. There's a rule that says if you have the natural log of a to the b, the a has to be raised to the b. What it allows you to do is bring the b down in front, and then you'll have the natural log of just the a. Okay? But what if you have the natural log of a, and then the whole thing is raised to the b? You cannot execute this rule. If the log is part of the thing that's being raised to the power, you cannot bring that down in front. Alright, so don't get that mixed up. It's when the inside only is raised to that power. And so when we're here, there's no 2. We can't bring this 2 down in front. This is the product rule. 2 functions multiply by each other. We'll call this one the first, and we'll call this one the second. And so we'll execute the derivative by taking the derivative of the first and multiplying by the second, putting the plus sign, leaving the first alone, and then we'll go to take the derivative of the second. Now in this second function here, we have this this natural log of x, who is squared. Really, that's a function inside of a function. To take the derivative of such a thing, we'll do the power rule, where we bring the power down in front and take it to 1 less power. And then the chain rule says, well, wait, multiply by the derivative of that inside function, and log x's derivative is 1 over x. So this becomes simplified as 2 log x all over x. And that's your derivative. Well, wait 1 minute. We had an x from here, first function, and an x in the denominator here. These guys are going to cancel. And so what we have then is simplified to be the ln of x quantity squared plus 2 ln of x. We want to know what that's equal to 0 at. So we set that equal to 0, and hopefully, I don't know if you can see it, hopefully you can factor out an x. And you'll be left with the natural log of x plus 2 being equal to 0. Let's go to another slide. So we have letter C, taking the derivative, and what we're getting is the natural log of x quantity squared plus 2 log x after canceling, and we're going to set that equal to 0. We're going to factor out a log x, be left with the log x plus a 2. Either log x is 0 or log x plus 2 is 0. When you want to get inside of a log, you make it the exponent on e, both sides. And so it'll be the fact that x is equal to 1. The way things cancel there. This time though, what you're going to do is isolate the log term. It was already done for you last time. So now we have natural log of x is -2. And now we make both the exponent on e, and we get the fact that x is e to the -2, which is like 1 over e squared. It's about a 1/9. And these are the two values that make the derivative equal to 0. So these are your critical numbers. Okay, great. And then lastly, letter D has a function of the sine of x squared. That's how we normally write it. And then they give us an interval because, you know, these functions that are periodic can go on forever. They want us to only focus on 0 and 2 pi, not including 2 pi. The bad thing about how we write these powers of trig is that it could be confused for inverse, and so we want to actually write it as the entire function sine of x who is squared. They mean the same thing. And then it's more instructive about how we proceed with this question, knowing that it looks like this. When it's time to go take the derivative, we bring down the 2, we take sine x officially to the 1, and then we multiply by sine x's derivative, which is cosine x. So this is the power rule, leave the inside alone, and then the chain rule, multiply by the derivative of the inside, and we're going to set that equal to 0. And so we have 3 things multiplied. 2 is not 0. Sine x could be 0. Or cosine x could be 0. Sine of x is 0 at, in our interval now, is 0 to 2 pi, not including 2 pi. So we get x equals 0 and x equal pi. Thinking of the unit circle there. Now cosine x is equal to 0 2 places as well. We'll get x equal pi over 2 and x equal 3 pi over 2. And that's it. answered that question. These are your critical numbers for that question. And we're all done. 4 different critical number questions, all in one. Good job.